So hopefully that you've been taking some time now to look at this. You're like, how am I supposed to know what this little portion is? So you probably looked at this and said, I probably don't have enough information. There's something else we need to know on this side in order to be able to find this amount. And so what happened is that we assumed that this person in the tower, that that distance was important, that height was important. Well, technically, the person from an observation tower versus the other person who may or may not be in an observation tower because it didn't tell us is on the ground. They're technically probably at the same level. So what that tells me is that this diagram is probably too complex and that this was probably more straightforward in what it was trying to tell us to do. So what do I mean? It says that there's a balloon up in the air. Okay, so I'll still call it B for balloon. It says that there's a person. Okay, so a person's over here looking up at the balloon at an angle of elevation of 68 degrees. Then there's another person. The balloon is sighted by another person 35 kilometers away. So away from the first person. Here's person 2, which we'll call C, who's standing 35 kilometers away from the first person. See what happens when you don't read into the question properly. And they look up 47 degrees, which tells me that they're further away from the balloon than this person, because this person has to look up more steeply. What it wants us to find now is how far is it from the balloon to the first. So much more simpler diagram. So this is what I mean by reading in too much and making diagrams way too difficult. This one had 2 dimensions going on here with height being very difficult for us. If we put them on the same level, meaning the tower, maybe this person's in a tower too, who knows? But if the tower is negligible in height based on the overall height of the balloon, or their equivalent, then it doesn't really matter. So what we have is this situation where we have an acute triangle with 2 angles, and I'm trying to find little c, right? That's what the question's asking us for. I don't have 90 degrees in this, so I can't use SOHCAHTOA. Do I have an angle side combo? Well, I have this angle, but not this side. I have this angle, I'm looking for that side, and I have this side. I can find this angle. So step 1, for angle B, dot, dot. So we write angle B equals 180 minus the 68 minus the 47. So 180 minus the 68 minus the 47 is 65 degrees. So now that I know that this is 65 degrees up here, that sets me up for sine law. So sine law to get little c. So for little c dot dot, since I'm looking for a side, I'm going to put the sides on top. C over sine c equals little b over sine capital B. C over sine 47 equals 35. I'll leave off the 0.0 over sine 65. And again, because we were smart, we put what we wanted on top. This just comes up and multiplies on the other side. And we just multiply that numerator together. What do I have? Sine 47 equals times 35 equals divided by sine 65 equals 28.2, and it didn't specify. So 28.2. Therefore, the balloon is 28.2 kilometers from the tower. So basically person A. So again, much simpler way of attacking this problem than trying to draw things too precisely as far as tower, person off the ground. We didn't know what this person was doing. Were they also in a tower or not? The 35, was it just to the balloon? So this 35 kilometers away was from the tower. not from the balloon. So this is where we see that people go wrong when it comes to these questions because they're reading too much into it and they're making it much more difficult than it needs to be. And of course, the more you do, the more comfortable you're going to be with setting up the situation. So let's continue with the next one. And it says a squash player. Okay, squash is like indoor tennis where you play up against the wall. You hit the ball hard against the wall and it bounces and comes back, and your partner or your opponent is supposed to hit it back against the wall. So basically, you're never supposed to let the ball bounce more than once before you hit it back. So we have a squash player. So basically, this is the way a court looks. So you're in one of those rooms, right? So I'm just going to draw the room. What happens is the person, so P for person, hits the ball to the sidewall. Doesn't matter, pick a sidewall. I'm going to hit it this way. So you can bounce it off the sides or the front wall. And that was 2.3 meters away. And the ball rebounds, which means it bounces at an angle of 100 degrees and travels 3.1 meters to the front wall. So this is the side, this is the front. So it's going to bounce off the wall and go there, and this is 3.1 meters to the front wall, 100 degrees. Assuming this person doesn't move, how far is the ball from the player when it hits the wall? So that's what we're looking for. So A, B. So we're looking for little a. How far is little a? Now again, no 90 degrees, so we can't use SOHCAHTOA. I don't have an angle side combo, but I do have side angle side. I have two sides in the contained angle, so side angle side means that I'm going to be using cosine law. So it's definitely a cosine law situation, and I have the angle across from the side that I'm interested in, so little a squared equals b squared plus, I use the letter p, so p squared minus 2bp cos capital A. Sub in the numbers, 2.3 squared plus 3.1 squared minus 2 times 2.3 times 3.1 cos 100. All right, so cos 100, again starting at the back, times 3.1 times 2.3 times negative 2, that whole back answer. I'm not going to write this down. I'm going to continue, plus 3.1 squared. You can press equals if you want, plus 2.3 squared. Now this 17 number, remember that you're not done. Some people wouldn't even bother to write that down. What we need to do is we need to square root it while it's all still in there to give us our full number, 4.168. 479,701. But what was it asking us for? How far is the ball when it hits the wall? Okay, so it didn't really specify. Therefore, the ball is, these were one decimal place, so I'll keep one decimal place, 4.2 meters from the player. When it hits the front wall. All right. Okay, the last one in this section says, a canoeist paddles 34 kilometers in a south 13 degrees west direction. Okay, so again, you have to know your north, south, east, west. I'm going to do a pretty big compass rose here so I can put my diagram on it. Okay, so there's my north, south, east, west. North, south, west, east. So this isn't bearing, so you actually follow what it says. Go south first. So pretending they leave right in the center. This is where you start. You're going to go south and then tilt 13 degrees west. So something like that, where that's just 13 degrees. That's a really tiny 13, but that's what it says. Maybe I can make it a little bit better. 1, 3. All right, so there's my 13 degrees. So, and how far did they go? 3.4 kilometers. So that isn't a speed, it's not per hour. So that's what they actually ended up going, 3.4 kilometers. So they started here, they traveled south 13 degrees west, 3.4 kilometers. And then they changed direction. Then they went 8 kilometers north, 5.52 degrees west. So where you last left off, draw another compass rose. So where you last left off, like that, this becomes your new north, south, east, west, because now it's like starting fresh. That's their new starting point. Okay. What did they do? They went from here north, so north is straight up, tilt 52 degrees west. So for 8 kilometers, 8 is pretty far, so I'm going to make this line pretty long. Not more like that. So again, here's my north, here's my south, here's my west, here's my east. So north, this part here, 52 degrees west. And then that was 8 kilometers. Then say they finished here. Get the W out of the way. What does it want to know? What distance will she have to travel to return to her original position? So now we need to go back to the start of the whole thing and attach to make our triangle. There we go. So start, middle, third leg. Okay, so A, B, C. So what we now need to do is we need to figure out what do we have here. We have a triangle that looks like this. Okay, so I'm just pulling out the triangle without the extra stuff around it. That's our triangle. This side is 3.4, this side is 8. That's what we don't know. Okay, so that's the simple way of looking at it. Obviously, this is trying to set up a side angle side situation, right? Side, angle, side, use cosine law in order to find that missing side. The problem is the angle right now, because this 52-degree portion only goes to where the north is. So that means, I'll do it in a different color here, this portion is what you need. You need that little corner in there that's on the other side of the north. However, so if I blow this up here, this side is 52, right? That we have in our diagram. That side is 52, this portion. This side is what we don't know. But we do know this is 13 degrees. And because these are parallel lines, do you see the zigzag? Do you see the letter N or Z? So this is alternating angles. So because of alternating angles, the 13 that's here can zigzag and become the 13 in there. So this part here is 13 degrees. So that means angle B, the total angle B, is 52 degrees plus 13 degrees, which is a total of 65 degrees. So that whole thing is 65 degrees, which now allows us to use it for side angle side to set up for cosine law. So we just have to zigzag, and again, why we're allowed to zigzag? Straight up and down, straight up and down, these are parallel. This line and this line are parallel. They're both straight up and down. Straight up and down, straight up and down. Right? And this line is just some diagonal line. So zigzag, 13 degrees, 13 degrees. So because of that, we're going to find little b using cosine law. B squared equals a squared plus c squared minus 2ac times cos capital B. A is 8. What's the other one? 3.4 minus 2 times 8 times 3.4 times cos, what did we say, 65 degrees. Enter it all into your calculator, starting from the back, moving forward. Cos 65 equals times 3.4 times 8 times negative 2 equals plus 3.4 squared plus 8 squared, or you could just type in 64, 52.569566656. Square root that guy. B by himself. What distance? It doesn't say how many decimal places. So I'll say 7.25. That's 2 decimal places. Therefore, the canoeist will need to travel 7.25 kilometers to return to their original position, right where they started. So again, it's important that you look for these patterns in order to carry forward numbers that might be outside the diagram to start with, but they actually also exist inside the diagram to help you get a more complete picture. So then you're able to use the formula more properly. All right, so again, this was very good at going through our which formula do we use, so our thinking tree diagram, right? Knowing which type of formula to use, and also how to not overcomplicate a diagram when something more simply is what the question intended. I will always try to make my questions very obvious when it comes to where to put the various components. All right, until next time.